maritime domain is one of the most challenging environments to operate a drone. You have basically water in every state you can think of. You have ice, you have the spray water, you have fog, you have turbulences. Drone technology is not that advanced that it is able to handle all of these things while being totally autonomously flying. I believe that now and in the foreseeable future, we will need more security and surveillance at our maritime borders and on the high seas. Surveillance that's necessary for the protection of people who work there and also the security of our offshore wind farms that are very essential right now for our energy production. We love helicopters for their specific advantages. You have the ability to vertical take off and land, which does not need much space. They can have quite a large endurance and range. They can hover on a given spot, and they are not so susceptible to winds and turbulence. We have the so-called Artis family. It's actually a family of many different helicopters, and right now we operate 2 of them. The Super Artis, which is actually the largest we ever operated so far, and the Midi Artis, that is much smaller. The Super Artis, with its special configuration, it's an intermeshing rotor, is able to lift about 35 kilograms, and this makes it for us an ideal demonstrator for all of our research projects. In Kochstedt, the National Test Center for Unmanned Aircraft, we simulate missions in controlled conditions. Our exhaust gas experiment is set up of 2 things. On the ground, we have an inflatable column, or so-called skydancer, with a diffuser on top, which is simulating the chimney of a ship. And we are even able to put some artificial smoke in there. On the other hand, we have a winch device that is connected to the drone and can lower itself from the drone into the exhaust plume. The winch is located about 20 meters below the drone, so it's basically not in the field that is affected by the drone itself, and this is very essential for the experiment because then we can measure the exhaust gas as it is. The winch is able to keep this height regardless of what the drone is doing above it.
At the DLR Institute of Flight Systems in Braunschweig, our team focuses on developing onboard software for drones to make them more autonomous. In the maritime domain, there are many potential applications for drones, like for example infrastructure inspection, monitoring of ship traffic, or logistics for offshore wind farms. The ability to take off and safely land on ship decks is a key requirement for drones in these scenarios. Regardless of these tasks, it's very crucial that the drone plans its own mission very accurately so that it always arrives at the right place and at the right time. We tackle these challenges by developing intelligent planning algorithms that are able to account for the influence of the strong offshore winds on the drone's trajectory.
Autonomously landing a drone on a ship deck is a very challenging task. You first need to acquire a relative position to the ship deck, which of course moves a lot and rolls. So we use onboard cameras and AI-based computer vision to detect markings on the ship deck. Only if the landing pad is actually free of obstructions, the algorithm will give the clearance to land. In order to plan a trajectory all the way to the touchdown position, we need to predict the ship's motion a few seconds ahead into the future. The drone will never be able to actually follow this trajectory perfectly, and there will be deviations. This is accounted for in our maneuver planning, ensuring a safe autonomous landing. Our goal, of course, is to make these concepts work in practice. For that, we need a lot of testing and experimental setups to bring us as close as possible to real-life conditions.
The natural next step is to take it offshore. That means that we will be on a moving ship somewhere in the North and Baltic Sea to really show that the technology is ready to be transformed into a product and to be deployed for everybody who needs it.